Welcome to today's part of this SPSS methodology, this time with a unit on Logit Regression. What is Logit Regression? Logit Regression basically works like the normal linear regression we know about, but there's one significant difference. We said with linear regression that the dependent variable always needs to be metric. That's due to the fact that if we were to run a linear regression or an OLS regression with a dummy variable, a 0, 1 variable, any type of nominally scaled variable as dependent variable, it could be, let's take the easiest example, 0, 1 variable, that we get a result of more than 1 or less than 0. So something in between would actually make no problems, generate no problems. This would mean we could interpret this as perfectly sure that it's the 1 or perfectly sure that it's the 0. So being equal to 0 or being equal to 1. And all the values in between, that's like it tends more towards the 0, it tends more towards the 1. If it increases the values, like a positive coefficient, this fact might actually, if it increases, tend more towards the 1 category. However, the results could be possible that you get a chance of like 120% for this being the 1 category. This actually doesn't make sense. In this case, there's a slightly modified version of the approach of linear regression. This is the so-called Logit or Probit approach. They are not so dissimilar, just a slightly different function underlying this, distribution function underlying this, but in the end they can both solve the same problem. Okay, how can we run such a Logit regression? We go to analyze here, regression, we see we have here binary logistic, multinomial logistic, ordinal and probit. That's basically the main thing I talked about. Binary logistic, that's the case which usually is referred to as Logit or Probit. In this case logistic, that's Logit. Probit would be here. Binary means we have a 0, 1 variable as dependent. Multinomial logistic means we have a variable which is nominal, which has more than 2 possible categories. With Probit, both of those are under this one command. Then we can also have not only nominal or metric but ordinal data. Then we would run something like an ordered Probit or ordered Logit, and this can be accessed here with the ordinal. In this part we are only focusing on the easiest of the versions, which is the binary logistic part. So it could be something like you ask someone, would you like to buy, or would you buy this product? Yes, no. And then I can get results what actually impacts his decision to buy the product in a positive or a negative fashion. All those questions could be answered with binary logistic or as well with Probit. But we go here with the binary logistic, and the idea we want to follow here is we want to get an idea what might impact the fact that someone is married. As dependent variables, or here they are called covariates, we select income, age, gender and how much they spend on fashion and clothing. So we insert those 4 variables here and then just click OK. Starts with a short overview, and then we have the block 0, the beginning block. This is basically if we were to have no independent variables in our model, how good would this model then be? So here we see this is the model, we only use the constant. Then the second version, method enter, block 1, that's we include all our variables in the model. So this looks a lot like, or at least in some parts, what we know from linear regression. Here are our coefficients. That's for the coefficients. That's their standard errors. And in this case we can no longer use a t-test. So we use like an approximation of the t-test, and that's the Waltz test. The Waltz test, or the Waltz statistics, they are given here. And they work similarly to what we know from linear regression. So it's coefficient divided by standard error, giving the Waltz statistic. This results in a significance level. So I can use these significance levels to again get an idea which of the variables have a significant impact, or in other words, which coefficients significantly differ from 0. That's the case here for the QO2. QO2 is the H, and for the constant. So we have very simple model. The only thing which actually helps us, and this in a positive fashion, is the age. So the older someone is, the higher the chance that they are married. We see here Q1, gender doesn't have an impact, Q05, income doesn't have an impact, and Q06, how much one spends on fashion and clothing, well, obviously also does not have a significant impact. So much for the coefficients. If we take a look here at the model summary, we see two R-squares, and they are differently sized. This problem results from the fact that as we do not run a typical linear regression, we cannot use the R-squared as we know it. So we need approximations. There are two approximations which are quoted here. That's the Cox-Snell and the Nagel cookie. They're both only approximations with a slightly different formula, and for this reason they report slightly different R-squareds. So here we just have like approximates. We know we can explain roughly something between 20 and 30%. So this in total is not this bad of a model. This can also be seen here. This classification table, which looks, if you already watched the section on discriminant analysis, quite familiar. Because here we have the actual observed values and the predicted values. And we see here those are actually rightfully predicted, and here those are the errors. But the errors are smaller than the rightly predicted values. So we have an overall hit rate of above 70%. So 70% can be classified correctly with a model where basically only the age plays a significant role. And this is relatively good because, well, as it's stated here, the cutoff would be at 50%, so 50% would be random chance. And we can explain way more than this, so this is actually a suitable, if not perfect, but at least suitable model, which can also be seen here from being able to predict roughly 20 to 30% of the variance in the dependent variable. Well, this then already concludes our small excursus into the field of logistic, or generally non-typical linear regression approaches. I hope you enjoyed listening to it and, well, at least learned a little bit from it. If you want to see more of this type of videos, feel free to visit the rest of this SPSS methodology. Until then, see you and goodbye.